This is AP Pre-Calculus. We're on worksheet C for our review before our test from units 1 or topics 1.1 through 1.6. In this worksheet, we have 3 problems. They're all calculator based. There's no backside, it's just one page. Let's see if we can do this. So on the left-hand side of my screen, I have my calculator pulled up, and you can see that each of these functions, I've already typed them in already. We have these 3 functions entered as y1, y2, and y3. This is my advice to anyone that's taken an AP test. If you have a bunch of equations, you can enter them all at the same time. Don't delete an equation when you're done with it. The way that you can turn off equations is you come up the equal to sign, you hit enter, and when you scroll down, you'll see that one of them has a black background, which means that is the equation that is being graphed. You can graph multiple equations. If I hit enter on y2, you can see that y1 and y2 will now both be graphed. I'm going to turn off y2 because I don't want to see that when I'm working on my y1 function. So you'll notice also that I have my intervals between -3 and 3. I'm going to change the window here in a sec. The one thing I want to give is some advice. Remember that when you are entering these equations, that these negative symbols out front are going to be considered the negative symbol, which is below the 3, as opposed to the minus symbol below the multiplication symbol. So minus signs down here are actual minus signs, which is in between the multiplication symbol and the plus symbol. But whenever you have a negative out front, the way that you enter that is with the negative symbol to the right of the decimal and underneath the 3 on the calculator. All right, so I'm going to go ahead and make this screen a little bit smaller here. My iPad works. There we go. All right, so I'm going to set my window by going to my window button, and I'm going to change my window between, you can see -3 and 3. So I'm going to say, come up here and go from -3 to 3, to 3. And unfortunately, the calculator I'm using right now resizes my Xmin and Xmax to make sure that these points show up, but it's going to be mostly the same. So if I hit zoom and then zoom to fit, which is 0, so zoom 0, it will show this graph. So the very first thing that we want to do is we're going to make a sketch of this graph, and you can see that my my graph does go from like -3.2 all the way to +3.2 as opposed to -3 to +3, so it's a little bit off. Here's my best attempt to sketch this function. So I know it comes, I have my y-axis here, I have my x-axis right about here, and I have, maybe I'll change to a different color here. I'll switch to blue, and I can say my graph comes down here, it starts curving up, doesn't quite hit the x-axis, it comes back up, comes up through here, and then it has a maximum, and then it curves down towards the x-axis down here. So it's good enough. All right, so then we need to do the analysis. So what is being asked for over here? It's asking us, oh man, my screen is not working. I think it's a little bit dirty. There you go. Oh man, it's still not working very well. Where is our relative minimum? So to find the relative minimum here, we need to use our calculator. The way that we do that is we come over here and we want to do this calculation. So it's going to be second trace to do the calculation. And you can see option 3 is a minimum, so we're going to hit 3. And it's asking me, where do I want my left boundary? I'm using my arrow keys in the top right of my calculator to change where my cursor is. So right now my cursor is at, oh, it's way too far to the right. Let me move it back to the left here. It's off the screen. I didn't know that could happen on this calculator. But all right, cursor should now be on the screen. There it is. My left boundary should be all the way over here at, I'm guessing about -2. So if I have this left boundary come to right about there, and I hit enter, and then I hit my right boundary. It's asking for my right boundary. I'm using the arrow keys. I'm saying my right boundary is here. I hit enter. Normally it asks you to guess also, and I would guess any point in between the left and right boundary, but you can see that it's telling me, hey, you have this x coordinate, and I'm going to write this down over here as well. My x coordinate is -0.718. And you always round to 3 decimal places on all AP tests. And it also tells us the height is 1.007, but it's not asking for the height for the worksheet, it's only asking for the x coordinate. Next is asking for the relative maximum, which we know the relative maximum is right about there. We already found this point right here, so I'm going to try to zero in on this spot. So I'm going to do a second trace to do a calculation, and we're going to do a maximum, so I'm going to hit option 4. And then again, I'm going to use the arrow keys to scroll over to where the left boundary is. Left boundary, it doesn't have to be that close, like hit enter here, go to the right a little bit more for the right boundary, hit enter here. Usually it makes you guess, but in this calculator it doesn't. So it says, hey, your x coordinate is at, and I'll write this down, is going to be 1.986. And then from there, we can answer the following questions. It's asking, okay, where am I increasing? And you can see over here, if I highlight, I'm increasing from here to here. So between these two x coordinates, really. So I can say I'm increasing between negative 0.718 all the way to 1.986. And where am I decreasing? On the graph over here, I can say I'm decreasing between here and here and here and here. So that's going to be, and that goes on forever and ever, so I can use infinity. I can say between negative infinity to that negative 0.718, I'm decreasing along with the interval that is after 1.986, so 1.986 to infinity. All right, that's question number one, and then I need to do question number two. So again, I already have all these functions graphed. I'm just going to use my arrow keys to come up here and go to the left. And once it's hovering over the equal sign, I'm going to hit enter, so it's not graphing that one anymore. I'm going to hit enter on my y2 function, so it's graphing the correct function, and then I'm going to go to my window and make sure I have the correct window. Notice that it changed my window, so it's going to be between negative 3, and this window is going to be 3, and I'm going to hit zoom 0 to automatically graph this thing. So there's the graph. Let's go ahead and make a quick sketch. So I always start with my y-axis and my x-axis. So y-axis is here in this case, x-axis is right about there. And I'm going to do another color so you can tell the difference between my axes and my function. So it's going to come down past the x-axis. We have an x-intercept. It's going to come back up, and then it's going to have like a local max, and then it's going to come back down, and then back up again. This goes probably up to infinity. I could probably do a little better than that. This is going to come up a little bit steeper. Good enough. All right, so I have my graph, and I'm going to come back here, and I'm going to start doing my analysis. So it's asking, where do I have my local minimum? My local minimum happens here and here, so I'm going to need two different spots. So I'm going to do this really quickly on the calculator by doing second trace, doing a minimum, so option 3. So my left boundary, so key tip, you don't actually have to use the arrow keys. What you can do is you can manually enter in a number. I know that this number right about here is about negative 2.5, so I can type in negative 2.5 and go to that spot. And you can see the cursor is now at negative 2.5. I can hit enter. I think on your calculator, you just enter the number and it automatically locks that position in. And then I can say, if I just enter negative 1, it'll jump to negative 1. I can say that's my right boundary. And now I have my x-coordinate. It says my first x-coordinate of the two that I'm going to be looking for is at negative 1.551. Because it was a 0, but that 0 is rounded up because it was followed by a 7. We need to find the next x-coordinate, so I'm going to do a second trace to do another minimum. So this minimum is option 3, and my left boundary is going to be about 1, so right about there. My right boundary is going to be about 2, so I'm just going to jump over there. And it says, okay, between 1 and 2, the minimum between those values is at the x-coordinate, I'll do a comma here, 1.291. Alright, and I'm going to label these because I think that will be confusing later. So this spot right here where we had a local minimum was negative 1.551, and then over here was 1.291. So the graph is labeled as well. Okay, we need to find the local maximum. So the local maximum, you can kind of see it on the graph, is going to happen right about there. I'm guessing it's at 0, but it might be a little bit off. So we're going to use the calculator to check. We're going to do a second trace to do the maximum. So we're going to do option 4. My left boundary is probably like negative 1 is probably fine, and then my right boundary 1, and it will find yes. Okay, so in between negative 1 and positive 1, it wasn't 0 like I suspected, but it's actually at this x-coordinate of 0.259, which I will also label on my graph so I can see that this is at 0.259. Alright, so from here, we're trying to figure out where I'm increasing. So I'm going to highlight our increasing intervals. We are increasing from here to here and from here to here. So those two green intervals. So I want to say between negative 1.551 all the way to, looking at our graph, 0.259. So 0.259. That is the first of the two intervals. The second of the two intervals, it starts at 1.291. 1.291, and it goes all the way to infinity. Alright, so where are we decreasing? We can see over here with the highlighter that I'm decreasing all the way from negative infinity all the way to negative 1.551, along with from 0.259 to 1.291. So let's say that we want to go from negative infinity all the way to negative 1.551, and that next interval of 0.259, 0.259, all the way to 1.291. 1.291. All right, and finally zeros. So we've never been asked this question before, zeros, but there's a synonym for zeros, and that is an x-intercept. It's really asking where do we intercept the x-axis, and we can see that there are two of them. We have this one here and this one here. So here's how you do it. You're going to do a second trace on your calculator, and you'll see option 2 is 0. So the left boundary I'm going to go to -3, and the right boundary I'm going to go -2. And when I enter that, it says, okay, your 0 is at, the first one is going to be -2.405. Again, you want to round. I think the AP test allows you to truncate, which means if you don't round, it's fine. But I like practicing rounding. And the next x-coordinate, we're going to do a second trace to do a calculation of the option 2, 0. And it's going to be between, I'm going to say between 1 and 3. You can keep the window super big. The calculator can figure it out from there. So from 1 to 3, and it says, okay, the 0 is at 2.049. Excellent. All right, so now we're on to the third equation. So I'm going to come back here to my y equals, and I'm going to scroll over here to undo this equal to sign, and what's going on here? Come on, calculator. So I'm going to come up here, I'm going to undo this equal to sign, and I'm going to enable this equal to sign. So y3 is being graphed. Notice that our window is very different now. Our window is between 0 and 6.5. So if I come here to my window, I'm going to change this from to 0 and to 6.5. I'm going to do a zoom 0. Again, it's slightly zoomed out, so it'll look kind of the same on yours. So let's go ahead and do our best to sketch this thing. Technically, that y-axis shouldn't even be showing if I'm going from 0. So I should really only have an x-axis, and it happens right about there, I would say. Let's change the colors for my graph, and it stays underneath, and then it comes down. Oh, it came down too far, didn't I? So it stays underneath, it comes down a little bit, and then it comes back up, and then it shoots straight down. There's my sketch. Okay, and now I'm trying to find a local maximum. So the local maximum, clearly happens right here. So we're going to try and find that spot, and I'm going to do a second trace, and then max is going to be 4. And my bound is going to be between, I don't know, 4 and 6. I'm going to make it super large window, so between 4 and 6. And it says that the maximum happens, and I'll write this down as well, at the x-coordinate 5.079, and I'll label it on here as well. So this maximum right here happens at 5.079. It's asking for the absolute minimum, which is interesting. I think this is maybe a typo. We should really be asking for the relative maximum here. If we're asking for the absolute max or minimum, then there is none for this function because it goes down forever and ever over here, right? So this function continues to go down and down and down. There is no absolute minimum because there is no minimum. It keeps going down. But if we're asking for a relative minimum, then we could be asking about this little blip right here where it has a relative minimum. So let's go ahead and try to find that point. So I'm going to switch the problem to be a relative minimum, and we're going to find the height here and the x-coordinate here. So this is interesting because we're actually finding the height for the first time, and I'll show you how to do that. It's just more information on the screen. So we're going to do a second trace to do a calculation of a minimum, so option 3, and it's going to be between, we'll just say between 1 and 3. So between 1 and 3, and that's going to happen at the x-coordinate, which we're used to saying 1.409. So that happens right here at 1.409. But it's also asking, what is the height? This is asking for the height here, and that's the y-coordinate that you're seeing listed right next to the x-coordinate. The y-coordinate here is -6.944. It was a 3, but I rounded the 3 up because it's followed by a 7. So on what intervals is h increasing? Well, let me go ahead come back here and highlight. Where am I increasing? So I'll do that in green. I'm increasing between here and here, and I'm decreasing between here and here and here and here. So I'm only increasing on this green window. That increasing amount is between 1.409, or sorry, that's, yeah, 1.409, I had it right, 1.409 all the way to 5.079. And it's decreasing on two intervals. The first one, it goes from negative infinity all the way to 1.409. And the second interval is from 5.079 all the way through positive infinity. And finally, we need to find zeros. Again, a synonym for zeros is our x-intercept. Our x-intercept happens, we need to do that with a calculator, so second trace and then hit option 2 for our zeros. And my left boundary, I'm just going to make it -2. And my right boundary will make it 4. And I get this x-intercept at 2.337. And I have another x-intercept. I'm going to do a second trace to do a calculation of a 0. And that's going to be anywhere between 5 and 6. No, 5 and 7, I think. So I'm going to hit clear. It's 7. My right boundary is 7. And that happens at 6.207. 6.207. Excellent. All right, well, that completes Worksheet C for our review for topics 1.1 to 1.6 right before our test. Thanks for watching.